All right, guys. Thank you all for coming. Today, we're gonna take a look at the properties of logarithms. Look, in the past class, in the previous class, we saw these types of properties, right? The basic facts, right? These are properties of logarithms that are so simple that we call them basic facts, right? Today, we're going to study some other properties that are not so simple. So as I said at the beginning, if you get confused at any moment, just let me know. I'm here for you. All right, let's begin with the first one. This is the first property. Let me explain it and do an example of this. This property explains the following. Whenever we have a logarithm, doesn't matter the base doesn't matter. But inside the logarithm, look in the parentheses, inside the logarithm, we have a power, right? A power. This means a base and an exponent, a power. Whenever we have that, we can transform that, right? We can change that. Instead of having a power, we can take the exponent and move it in front of the logarithm as a factor. Here it is. Remember, factor is just a fancy word for multiplication. So there it is. The n is being multiplied by the logarithm. Huh? So we can do that. Here is an example. Pretty simple example, all right? How much is the logarithm to the base 7 of 9? Let me erase this. Of, I don't know, 49 to the 100. What? Man, I don't know. I don't know how much that is. All right, but we know, thanks to the property, we can remove this exponent and move it in front of the logarithm, right? So we have 100 times the logarithm, base 7 of 49. All right. In this case, of course, we can expand this even further, right? We know that this is 100. And how much is the logarithm base 7 of 49? How much is that? Right? In other words, to what value do I elevate this 7 so that the result is 49? That is the logarithm, right? Remember, logarithms look for the exponent, right? So to what exponent I elevate the 7 to get 49? Well, 2. So this is 100 times 2. And in this case, this is just 200. And we found the solution to this thanks to the property. All right. Cool, huh? All right, okay. All right. But we can also use this property backwards. We can use the property backwards. Here's an example. How much is this? I don't know. How much is this? How much is 2 times the logarithm base 3 of what? Here, base 6, logarithm base 6 of 18. There it is. How much is that? How much is that? How much is that, guys? Well, you might be saying, all right, let's find the logarithm base 6 of 18. So to what exponent do I elevate the 6 to get 18? I don't know. It's not 2, right? 2 is 36. So no, it's not 1 because 1 is 6. So it's definitely a decimal. 1 point something. So I don't know. But what we can do, for sure, is transform this into a logarithm with a power, right? So we can move these 2 and put it over here on top of the 18. This will be the logarithm to the base 6 of 18 to the second power. All right, 18 to the second power. All right, that is 18 times 18. Now, I have no idea how much that is, so we're pretty much going to stop our solution right here. But we can apply that, right? We can do that property backwards, just like what I'm saying is we can do it from left to right, or we can do it from right to left, right? We can do it backwards. All right, that was the first property. Let's jump into the ones that are a little bit more complicated. Or not complicated, confusing. Can be confusing. All right, property number 2. Take a look at this one, guys. Take a look at this one. Take a look at this property. This property explains the following. Look, whenever we have two logarithms, look, 1 and look the other one, 2. Whenever we have two logarithms, but these logarithms have a condition, right? Have two conditions. Conditions, right? Number 1, the first condition. Both logarithms have to have the same base. Whenever we have this, right? If the logarithms have the same base, and the second condition, the second one, in the middle of the logarithms, you have an addition, this one, an addition. Addition, there we go. If we have these, if our expression have these two conditions, then what we can do is compact. So simplify the expression into just one logarithm alone. Instead of having two, look, 1 and 2. Instead of having two, we can merge them together into one. The result will have to have the same base. Look at that, the same base. The base was A, and A, right? All right, and what did you do with these two values, with X and with Y? What did you do with those? Simple. We are going to multiply them. X times Y. Multiply them. All right? That's it, guys. That's it. That's the property. Now, let me show you an example of these. All right. All right. Example 1. All right. Here's a good example. How much is the following? All right. Let me choose two values that I can find the answer to. No. No. All right. How much is the logarithm to the base 18? Right? Let me do this G again. Logarithm to the base 18 of 6 plus the logarithm to the base 18 of 3. How much is that, guys? How much is that? Again, you need to think about the first logarithm. So how much is... No. Let me put it again. 18 elevated to the what exponent gives me 6? No idea, right? Has to be a decimal. No idea. Again, 18 elevated to what exponent gives me 3? Same, no idea. It has to be a decimal, but we don't know without the calculator, right? But what we can do is take advantage of our property. Look, we have two logarithms that are adding and have the same base. So we can compact them into just one logarithm. The resulting logarithm will be base, same base than the previous one, so 18. And in the middle, right, you're going to multiply both numbers, so 6 times 3. There it is. The result will be logarithm base 18 of 18. And now we know the answer to this. Now we know the answer to this. How much is this, guys? To what value do I elevate the 1 so that the result is 1? Everybody in the chat, please. Everybody in the chat, tell me right now. How much is this? How much is this? Everybody. All right. Beautiful. Thank you, guys. You are correct. In fact, this is one of the basic facts that we studied the previous class, right? 18 elevated to the first power is 18. So the result is just 1. This is one of the uses of properties in logarithms. But like I said at the beginning, we don't have to do this from left to right. We can also do this from right to left. So we can have one logarithm and we can expand. Instead of compacting the logarithm into one, we can have one and expand it into two. So exercise 2. Let me think about which one. No, these no. I don't know which one. All right, I don't have a good example, so I'm just gonna do the logarithm like this. Logarithm base what? Base 7, right? Of 70. Of 70, right? Logarithm base 7 of 70. So how much is that? All right. For once, we can just expand the logarithm into 2 multiplications. So we can say the 70 is 7 times 10, right? And now that we have a multiplication, we can expand the multiplication into 2 logarithms. Now, both logarithms will have to have the same base. So say base 7 and the other one base 7 as well. Since we had a multiplication inside, we can expand it with addition, right? And both values are going to go to each logarithm, right? Each value is going to go to each logarithm. So here a 7 and here a 10. All right. Of course, we can simplify this a little bit. This is logarithm base 7 of 7. This is 1, right? So this is 1 plus the logarithm base 7 of 10, which is, I have no idea how much that is. We're going to have to use a calculator for that one. All right, second example. So again, we can compact logarithms into 1 or expand them into 2. That's it. That is our property. Let's jump into the next one, and you will see just by the look of it that it looks a lot like the second one. It is really, really similar to the second one. The only difference is that this time we are working with subtraction. Take a look at these guys. Take a look at these. All right, so again, just like in the previous one, we have 2 logarithms. One logarithm and the other logarithm. But we have 2 conditions. Conditions. There we go. 2 conditions. Number 1, both logarithms have the same base. It is really hard, guys, for me to write using my mouse. Sorry. You have the same base, right? So base A, and base A, right? Doesn't really matter the base. It can be any value just as long as the base is the same. And the second condition, guess what? Condition is that in the middle of the logarithms, you have a subtraction. Subtraction. I am so sorry, guys, about that. I think you understand the idea, right? Subtraction. So if we have an expression that has these 2 conditions, then we can apply the property. And what is the property? Well, we can compact, just like in the previous exercise, we can simplify both logarithms into just one. The resulting logarithm is going to have the same base. Look, base A. And what do we do with the values? What do we do with those? Simple. The first logarithm will be divided by the second one, right? The first value will be divided by the second one. So we have x on top, up, and y, the second one, down on the denominator. Down. This is a D. Down. All right, there it is. All right. Okay. Now, in this case, you need to make sure you are following the proper order. Again, the value that goes first goes up, right? The second value of the logarithm, the second, goes down. All right, guys? So you need to make sure about that. You need to make sure about that. Follow the order and we will be okay. Now, it's time for a little example. Let me see. Let me see what values I can think of. What if I do? What if I do? Ooh, that looks nice. Yes, let's do that. All right. What is the logarithm base 3 of 18 minus the logarithm base 3 of 6? How much is that? How much is that, guys? How much is that? Huh? How much is that? All right, so you might be thinking, all right, let's think about a value that I elevated 3, right? So 3 to the what value do I elevate it to that I get, say, 18? 18, right? So 3 to the first, no. 3 to the second, that's 9, no. 3 to the third, that's 27, so no. It was 2 point something. Man, it is a decimal, so it's not easy, right? So we're gonna have to use the calculator for this one. We're gonna have to use the calculator for this one. All right. How about the second though? Can we do the second one with our minds? All right, so 3 elevated to the what exponent gives me 6. This is what I'm doing. 3 to the what exponent gives me 6. Well, I don't know either, because 3 to the first is 3. And 3 to the second is 9. So no, it's a value between 1 and 2. 1 point something. It has to be 1 point something, right? So what is that? What's the answer then? This is an example that we're gonna have to use our calculator for as well. We're gonna have to use our calculator for this one. Man, unless I remember there is a property. Look at that, the property. The property says if we have two logarithms, both have the same base, and in the middle you have a subtraction, you can simplify that expression into just one logarithm. The resulting logarithm will have the same base, so base 3, and in the middle, right, so the value of the logarithm will be a subtraction. The first, right, divided by the second one. Oh, that was a 6. Here, divided by the second one. And this is something that we know. This is something that we know. This is the logarithm base 3 of 3, right? 18 divided by 6. That's 3. And we all know the answer to this one, right? We all know the answer to this one, right? Huh? Did you see? Did you see? Did you get it? All right, guys. Okay, cool. All right, cool. This is one of those properties that you don't want to miss, right? Because this property is so powerful that when you mess it up, if you, for example, if you forget that the first value goes up and the second value goes down, if you forget that, then you will have problems with your answer. But look at that. This is the strength, the real strength of these properties. Again, just like in the previous one, we can use the property instead of doing it from left to right, we can do it from right to left. So we can have a logarithm that happens to be a division, and we can expand that division. So let's do this. What is the logarithm? Base what? Base what? Base 5 of what? Of what? Let's say 2. This is a good example. How much is the logarithm base 5 of 2? How much is that? How much is that? How much is that, guys? 5 elevated to the 2. No. 5 elevated to the what gives me 2. So to the first, no, because that's 5, so no. To the second one, no, because that's 25, no. So it has to be a value lower than 1, right? 0 point something. But we can do this, or we can approach this with our property. So we can expand this, right? But there is no division here, teacher. You said you needed to have a division. Look, division. Sure, but we can transform the 2 into a division. Here's what I mean. We can say that this is, I don't know, 50 divided by 25, for example. For example, right? 50 divided by 25. 50 divided by 25, that's 2, right? That is 2. I'm not doing my math wrong here, right? That's correct. 50 divided by 25, that's 2. Great. So we can expand this into 2 logarithms. The first one, this was base 2, base 5, right? So logarithm base 5 of 50 minus the logarithm base 5 of 25. Now, we don't know the answer to the first one. We don't know the answer to the first one, right? It is 2 point something. We don't know the answer to the first one, so we're going to leave it just like this. Logarithm base 5 of 50. But what we do know is the second one. To what value do I elevate the 5 to get 25? Again, to what value do I elevate the 5 to get 25? Huh? 2, right? All right. So again, in this example, we didn't know the answer to the full to the question. We didn't know the full answer, but we kind of have a good approach. Again, this 50 can be expressed as 5 times 10, right? So we can expand this even further. All right. I'm going to leave that to you guys. All right. These are the 3 properties from here. We have a 4th property that we're not going to use today, so I'm not going to explain it right now. By the moment we use this property, we are going to come back and I will explain it, all right? Don't worry about this one. All right, so it is the time for some exercises, or some examples, rather. Let's write this logarithm that we have here, logarithm base a of x times the square root of x squared plus 1. Looks awful, I know, believe me, I know, but I'm going to show you that it is not awful. And the more you practice, the easier this is going to get. All right, we're going to write this logarithm as a sum of logarithms, right? So we know at the end, we need to have a bunch of logarithms being added, right? Sums, so addition. And we also need to make sure we express the powers as factors. So we are making good use of the second and the first property. Second property means addition of logarithms. First property means exponents or powers as factors, right? Okay, this is how we do it. First step, we're going to write down the question. From here, we recognize that these, inside the logarithm, we are multiplying things, right? We have a multiplication. Look, the x is multiplying the root. That's right, x times root. Since that is a multiplication, we can expand it into 2 logarithms that are adding, like this. The first logarithm, of course, with the same base a, base a, base a, right? The first value of the logarithm is going to be x, the first factor, right? X. And the second value is going to be the second factor. Remember, factor is just a fancy word for multiplication. Here we had multiplications, so we had 2 factors. X is the first factor, and the square root of x squared plus 1 is the second factor. There it is. There it is, guys. There it is. Did we finish? Nope. No, we did not finish. We did not. Because in case you don't remember, I'll tell you right now, you can change roots into exponents. You can transform roots into exponentials. And how? Like this. The root goes to the corner, right, as an exponent and becomes the exponent 1/2. All right. So now we have the logarithm base a of x plus the logarithm base a of x squared plus 1 to the 1/2. To the 1/2 power. All right. Beautiful. And look at this. We need to express all powers as factors, which means we need to get rid of this power. This exponent needs to go to the front of the logarithm, like this. Final result. This is the moment where you take a picture because this is the final result. Logarithm base a of x plus 1/2 of logarithm base a of x squared plus 1. There we go. We effectively write down the first logarithm as a sum of logarithms. Look, there is a sum of both of two logarithms. And we express all powers as factors. Look at that. As factors. All right, congratulations. Pretty good, huh? Let's jump into the second exercise. This one has a division and, more important, says ln at the beginning. What is ln? Guys, in the chat, please tell me. What is ln? Everybody. Open your notebooks, go back to the page where I explained this, and tell me. Tell me. What is ln? Everybody. ln. What is that thing? What is that thing? What is ln? All right, thank you guys. Thank you to all the people who write it in the chat. It is the natural logarithm, the natural logarithm. So it's a special type of logarithm. Is the logarithm base e? Yes, sir. Yes, sir. So every single property that we have talked about can be applied to this logarithm because it's just another logarithm. Sure, it's a special one, but it's a logarithm nonetheless. All right. Solution number one, or first step. We're going to write down the question. Notice how in each of these questions, I am disregarding this, x bigger than 1. I did the same in the previous one. Look, it says here x bigger than 0. And I did not mind that at all in my procedure. Look, this is just because this is here to tell you the domain of this logarithm, the domain, right? So this is something good to know, but we're not going to use that in our expanding. Same here. X bigger than 1, but we are disregarding that because we don't care for now. We don't care for now about that. All right. What do we do first? Well, we recognize that we have a fractionary, right? We have a fractionary inside the logarithm, which means we have a division. And we know if we have divisions, we can split it into two subtractions, right? So here it is. The one on top goes first. X squared goes first. And the one down, x minus 1 cubed, goes in the second one. We need to leave the same base of the logarithm, right? Since this logarithm is a special one, is the natural logarithm, we're going to have natural logarithms on both sides. All right. What do we do now? Pretty simple, huh? We have here a power, x squared, and here we have another power, x cubed. So we can transform or express those two powers as factors simply by changing them and putting them in front of the logarithms, like this. 2 times the natural logarithm of x minus 3 times the natural logarithm of x minus 1. There it is, guys. There it is. There it is. Go ahead and take a picture. That's it. That's the answer. That's it. This is the simplest form. Now, some of you might be thinking, but teacher, look, come on. There's a logarithm and you have a subtraction here. Can we expand this? No, we can't. Because the property, if you take a look at this, let me erase all of these. Let me erase all of these. There we go. Because the property says that if you have a subtraction, you can compact it into a division, right? That is from left to right. Subtraction goes into division. Compact it. But if you want to expand it, you need to begin with division into subtraction. What we have here is a subtraction inside the parentheses of the logarithm. We can do anything. We cannot expand this or we cannot simplify it. There's nothing we can do. That is not what the property is saying. Let me do this a little bit smaller. Look at this. This is not what the property is saying. In our example, we have natural logarithm of x minus 1. There's nothing there. We can't do anything. There's nothing we can do. We need to have a division, not a subtraction. If these were two logarithms, right, like this natural logarithm of x minus natural logarithm of 1, if this was like this, then sure, we can compact them, but it is not, right? It is not. We cannot expand this. This is why I said at the beginning that people were going to get confused, because this will happen to some of you. You're going to go like this. Oh, a minus. I can expand it. And you cannot. You cannot. All right. This is the final solution. If you're taking pictures, go ahead and take one of these right now. All right. Third and final example. Third and final example. Here it is. Logarithm to the base a of a huge expression, the square root of x squared plus 1 over x cubed times x plus 1 to the fourth power. This looks entirely awful, but it isn't. It isn't. In all honesty, it isn't. You just need to follow the rules and try to be organized. If you're an organized person, if you like following the rules, you're going to have a good time. If you are really disorganized, man, you're not going to have a good time. You're not. You're not, because you're going to get lost. You are. All right, how we do it? How do we do this? Again, the example is telling us to write this as a difference of logarithms and also express all powers as factors. So how do we do this? Simple. Solution. We're going to write down the question first. Logarithm to the base a of the expression, right? And then we recognize this is a fractionary. So we have a division, right? We can expand this into two subtracting logarithms. Both logarithms have to have the same base. So the base here is a. We need to have both in the same a. Here it is. There it is, guys. Logarithm to the base a of the numerator, right? Minus logarithm to the base a of the denominator. There it is. There it is, guys. But wait a minute. Wait a minute. Look at what we have here. We have a multiplication. This is x cubed times x plus 1 squared, or to the fourth power. This is a multiplication. So we can expand this even further, right? Yes, we can. We can expand this into addition, and this is how it goes. The first logarithm, you're going to leave it alone because we're not doing anything to it yet. And for the second one, we have the first factor in the first logarithm and the second factor in the second logarithm. X cubed and x plus 1 to the fourth. There it is. There it is. Now, what do we do next? All right. I'm thinking, let's get rid of that parenthesis. You know what? The teacher never said anything about parentheses, so I don't like that parenthesis. Let's just get rid of that. Okay, but in front of the parentheses, we have a minus. If in front of the parentheses we have an addition, we can simply erase the parentheses, but that is not the case. We have a subtraction, which means we need to change the values or the signs of these two logarithms. This one is positive right now. This logarithm here in front of this is positive. So this logarithm will be negative. And this logarithm is also positive. So this will be negative as well. Like this. The first logarithm, we are not doing anything to it yet. And for the second one, look, minus, right? So that means this logarithm is negative. And another minus. So this other logarithm is negative as well. That happened, again, because there was a negative in front of the parentheses. All right. Cool. What do we do now? All right, now we get cracking. Now we get to the real deal. Look, here. We have a square root of x squared plus 1. A square root, again, a root. And just like in the first example, we can change this root into a value that we know, an exponent, a power. The way we do that is we elevate this x squared plus 1 to the 1/2, like this. X logarithm base a of x squared plus 1, so the same value, to the 1/2. And now that we know, now that we can see we have 3 exponents or 3 powers inside the logarithms, we can move those exponents as factors. Look, these 3 in front, these 4 in front, these 1/2 in front. You can do that like this. Final result. This is the moment where you take pictures. 1/2 of logarithm base a of x squared plus 1 minus 3 times the logarithm base a of x minus 4 times the logarithm base a of x plus 1. There it is. There it is, guys. There it is. We have 3 logarithms, right? These logarithms are subtracting, so we express this as differences. Remember, difference is the same as subtraction. Subtraction, right?
Mr. I have some questions.
Yes, sir.
In the first step, why we didn't put like the square parentheses in the logarithm too?
What? In the where?
In
In the
the
what?
first step,
So here?
no, in
Here?
the part of the equal, yeah. Why we didn't put that parentheses in the logarithm?
What parenthesis? This parenthesis?
Yeah,
It is here. Look at that. It is right here.
yeah, but why not with the logarithm like down?
Because of that, look. At the beginning, we don't have any parentheses in the denominator. So that is why we don't have any parentheses in this part. Remember, this part is the logarithm, right? Is the denominator, right? But we needed to put these parentheses. We needed to put these parentheses here so that we remember that when we expand this, the minus will be applied to both. If we didn't put these parentheses here, we would just think that the minus will go to the first logarithm. The reason we don't put it at the beginning, is because it doesn't really matter. You need to make sure about these parentheses here because it's the one is going to transform in this one. If you put a parenthesis here outside, I mean, sure, you can do that, but it doesn't really matter. Sorry. You can put a parenthesis here outside the logarithm, right? If you want to. But it's not going to change anything. It's not going to give us or take us or take from us, right? So that's why. That's why we don't put any parentheses here outside.
Okay, Mr. Thank you.
All right. Okay. All right. All right. That's it, guys. That's it. That's it. These are the properties of logarithms. Some of the properties of logarithms. There are a lot more properties, and we're gonna see those properties eventually, right? When we need them. We were gonna talk about those properties when we need them. As of now, just these 3. But now it is your time to practice. Guys, please go to page 457, exercises 29 to 70. Just do the odd ones. And guys, today we have 15 minutes, or rather 12 minutes to finish this class, or this half of the class, and then a whole hour. So yes, I expect you guys finish these exercises today. All of these, please. Remember, you guys are not alone. If you want to check your answer, or maybe you are stuck at some question or some process, or I don't know, you simply didn't understand something and want me to explain it again, ask me. I am here for you guys. In the meantime, I'm going to cut the video and let you work.